with this stuff, again, to show you guys a really nice visual representation and how you can set up 3 other types of similarity problems that we'll come across in this unit. I'm not going to bore you with all the long-winded versions of why everything works itself through, because there's, quite honestly, if you see the picture and you understand the diagram, setting up the fractions is really simple then. For example, one of the things that we can have is that if you have a triangle, we take a triangle and we draw a segment parallel to one of the sides. Doesn't have to be it doesn't have to be any place in particular. It could be anywhere. We'll just put one here. And I'll say that it is parallel to that side. I can do this 3 different ways. I'm just going to draw it in this version right now. So what happens is, if you have a triangle that has one other segment drawn in that creates, that's parallel to one of the other sides, if you think about it, this segment kind of creates its own fraction. That segment, that parallel segment, think of it as a fraction bar between the 2 sides. It splits the side into portions. It makes it proportional. It's a very visual way of doing something. There's no extra wording or anything you have to mess with, because if you start to think about long way through this, everybody agree that that top angle would be shared between like a small triangle and the big triangle? And then with parallel lines, you get corresponding angles and so on. So you wind up with that angle-angle similarity without having to say you have angle-angle similarity. As long as you've got a line that's parallel to one of the sides, it creates a fraction here and a fraction here. That's all it is. Let me show you what that looks like in a diagram. And I'll put it up on those. Oops. I accidentally hit the whole page. So if I look at this, see how I have 2 sets of parallel sides? Take that parallel side that's inside the triangle, extend it through, and it makes a fraction. Yeah, exactly. It's that fast then. Because now you can write your fraction a couple of different ways depending upon how you read it. Well, let's shut one of those off because of the glare. You can write it up one of the different ways. If you tilt your head this way, you have 5 over x is 6 over 12. If you tilt your head the other way, you have x over 5 is 12 over 6. Does it matter which way you go?
No.
No. What's x? 10. It creates a fraction. It creates a fraction. That's all I'm getting at. Twist and turn the paper around, and you'll see that you get a fraction just by extending it around. It's that. It's that. What?
It seems like it should be harder.
We can make it more difficult.
No, I mean, it just seems like...
You're right. It seems like it should be. And if you go through, want to go through the whole long-winded definition of it, there's no reason to. Just remember that this line creates the fraction here, and it creates the fraction here. That's what it does. That interior parallel line makes a fraction. It splits it to a numerator and denominator. And just as long as you tilt your head one way and keep it tilted that way to make both fractions, you're going to be fine. Right? You okay with that? Okay. There's another one that we do. Sometimes you have more than one parallel line. Sometimes you have
3 parallel lines. If you have 3 parallel lines, you might actually get 2 transversals. When you have 3 parallel lines and 2 transversals, how many segments are created on the interior of the 3 parallel lines? See how I have 4 segments on the inside? What do you think that middle parallel line is going to create? Fraction. Tilt your head sideways. Tilt your head sideways, and all of a sudden you get B over A is C over D. Again, it creates a fraction. This line in the middle creates a fraction. And it all stems back from the idea of parallel lines cut by transversals. You get corresponding angles. So you get all these angles wind up being the same because you have interiors. You have 2 quadrilaterals. You have 2 quadrilaterals, and if you flip it, and how many degrees do you think are inside a quadrilateral?
5.
4?
No. 4.
Degrees. Angle degrees. 360. It's 360 degrees because, and we'll talk about this more second semester, because you can create 2 triangles inside a quadrilateral, they don't overlap, which means 180, 180. Oops. So what actually happens here is that these angles are the same, all those. This one's the same as, this one's complementary, this one here, and these 2 are, so there's a whole bunch of weirdness that goes on, but that's where you get your similarity. So again, what happens is you have 3 parallel lines. Two transversals. It sets yourself up as this one is your fraction. The ones right in the middle create that fraction. And you're right, it seems like it should be a lot harder than that. It really does. But all it's doing is just splitting it up. It's a matter of looking at a picture and just kind of in your head mentally twisting it around, tilting your head sideways, trying to see what's over what, and keep it consistent. Let me show you an example.
Ask him.
Oh, look at that. If I look at that, you've got 3 parallel lines cut by 2 transversals. Yeah. You have the 3 parallel lines. You actually have 2 fractions because if you look at, because you have all the numbers are on the inside of everything. So since your numbers are the segments that are on the inside here and here, those are your fractions.
Only the numbers on the inside.
Yep, because out here I don't know what the lengths are because it's a line. I know what the lengths are between them because it's a distance that has points. So it's just a matter of deciding which way you want to write it.
Could you do it either way?
Yeah, which way are you going to say?
I was gonna say 8 over 6.
So you're going to say 8 over 6 has to correspond to
X over, 10 over X.
10 over x. Good, I'm glad you caught yourself. You're right, because when you tilt your head to the right, 8 over 6, 10 over x, or take your book, take your paper, take your Chromebook, whatever, and spin it. There's your fraction. 8 over 6, 10 over x. If you spin it the other way, x over 10, 6 over 8. Doesn't matter which way it is. As long as you're consistent for both directions, you're fine. So you cross multiply it out, what do you get? 8x is
60. Divide that by 8, we go 30 over 4, 15 over 2, 7 and a half.
It's okay to get that.
Absolutely. Decimals are numbers too. They're just parts of one.
We just never really got.
Just trust the fact that you know what you're doing. How about this? These things are all similar. They're all getting the same ratio. 8 over 6 simplifies to be what? 4/3? So if you go in your calculator, does 10 over 7.5 simplify out to be 4/3? Think about it in terms of money. If you think about it in terms of money, 4 would be 250, 250, 250, 250 to get you to 10, right? 3, yes sir. 3 250s is 750. So it works. Okay. It's okay to have a decimal. Use your calculator, verify that you did it right. Okay. You look like you were worried. You all right?
We simplify this is all here.
Hit the double arrow button.
Make it not
Double arrow button.
I got it.
Look, that's enough for here.
Oh, I look like,
Look at that.
okay, hey, like you're being snotty with me. Hey, do you guys know what this double arrow button does on the calculator? All right, so little top tip for today, in case you forgot. If you go through your calculator and you put in there your fraction bar of 10 over, yeah, you don't have to. You gotta buy one of these, trust me. If you put in your calculator the fraction of 10 over 7.5, it will spit out the decimal of 1.3 repeating. Now, in order to verify what that, don't leave. In order to verify what that does to a fraction, the double arrow button automatically simplifies it to the fraction for you. Hit the double arrow, enter, and it does it for you. Okay? Double arrow is a pretty friendly thing to know. Okay? Double arrow is really nice.
Double arrow.
Double arrow.
Double arrow is my favorite arrow.
Stop looking so hard, it's right above enter.
Oh. I was really searching.
I was worried that you were kind of staring around like you're looking for double arrows. Like, are you looking at like an actual like a bow and arrow? Like somewhere on there, there's going to be an arrow
I was looking at like the.
with stuff like this on it. Oh yeah.
Oh, this is on our calculator.
Oh, okay, gotcha.
It's like we draw an apple and see if it sits on your head and you can throw it over.
I was like, what the heck?
I mean, if you want, we can do this and have some fun with it. So then,
Worry. Hey, nice clip art.
You like it?
That doofus right there. Oh.
Okay, that was rude.
It kind of looks like. There you go.
Kevin?
No.
Nigel.
That's all. How'd you get it? How'd you
So-
get there?
so you want?
Mr. Murphy, you want to see something?
No.
No, no, no.
So
like, seriously.
you want to shoot an arrow
I wanna
on
see
an
some
apple?
You missed.
I can do it. Nigel.
They're not applauding for you.
Duh.
What's up?
You want to see something?
No.
Yeah, do it. Yeah.
Please, we want to show you.
It's funny. It's Power Rangers. It's funny. Yeah.
I'm a Power Ranger.
Maybe
Me too.
later.
We're missing.
Maybe never.
No, it's so funny. You guys are so hilarious.
Hey, this last one you're gonna love.
It's math. You're gonna hate it.
Yeah, Tori ruined it.
No, I didn't. Yeah, Michael. No, I didn't.
It's trying.
So what I want to do here for the last example is I want to draw an angle bisector out of one of the angles. So
an angle bisector, if you look at it, an angle bisector will split a triangle into two proportional sides.
Even dirtier.
So here's what happens. This is what I mean by you're going to love it. If you start at a point at the angle bisector, go through it, and come back around.
It's a balloon.
And you do the same thing on this side.
It's a heart.
You're gonna
That's so cute.
love
It's a
it.
butt.
Oh, it's a picture of your face?
That's a butt.
Everyone's like, oh,
Dang.
A butt, a butt face?
There's no.
So, in this case here,
Oh,
hold on. In this case here, notice both sides of the heart creates fractions. A over B, C over D.
Whoa.
Yep. It goes out,
Next hour we're gonna what?
you go out and around. So, the trick is,
I'm gonna go to lunch.
you always start where the angle is being bisected. When you follow out, it becomes two parts.
It's like
Ele-
D over B.
What's that?
Continue.
It becomes two parts. These two parts are what go in the numerators. It follows around to the parts that they're proportional with. So yes, I joke about saying you're going to love this one, but if you draw that out, you're not going to get it wrong. Okay? It's same deal with all of these things. I'm showing you guys different visual ways of looking at a geometry problem, which is an algebra problem in this case. How do you draw something to help make it a little bit more sense of what to do to solve? Yes, sir.
With BC over AC, you cut it in half.
Doesn't say that I cut it in half. It's not necessarily that it needs to be cut in half. Okay. It's just an angle bisector. It's not bisector of the sides. Okay.
Did someone go to the bathroom?
I don't know.
We should leave the classroom like you said.
Oh wait, did someone go?
Or like turn
Can we
off all
do
the
that?
lights and stuff.
Yeah, then we all just.
Or sleep.
Come on, we said.
Mr. Murphy, please.
Look at it's an intruder drill.
So let's look at an example.
Cover everything and
Shh, guys, come on.
It's been more than 20 minutes.
This has like 25.
We just don't talk right
Yeah, he hates us.
You guys just put words in my mouth. I didn't say it.
now. But you're thinking.
No.
Yeah.
Yeah, because that's the shit.
Hey, Mr. Murphy,
I don't know anything.
has anyone ever told you that you have a face for radio?
Because when you're on the radio, you don't have to show your face. Haven't you got on my story? Can I ever laugh at my story? Can I just record it? I know that we're in this class. You were laughing at like 3 different moments of what's happening. Instead of just having sort of like, cracking around.
Like when I
Oh, you
was.
know what? I have to.
Wait.
It was like the other day.
Oh yeah. Oh yeah. We were joking out. Like, just seen anything.
Not only that, I'm
Or it's just
Come next time.
Okay, can I keep going
I mean, I invited you last time.
I am
You
too.
invited me?
I just thought about that. Mother of God.
Oh, I probably didn't go through because you're.
Oh.
Boy.
Now I'm there.
Because for real, right?
I will.
I have a little fresh little coffee.
I had like.
Sorry, and I just didn't drink it before I walked over yet. I take a I take a good coffee.
My dad drinks.
I do too. I don't put any like I don't put creamer or sugar in it. What I normally do is I'll buy a guys. This is a top tip for saving money as you get older. You will get bored by just plain coffee because
just kind of, but a good flavored coffee is good, but flavored coffee is expensive. You can buy a pound, just a little pound of the flavored coffee at Aldi for like $3.99 or whatever, like a French vanilla or a hazelnut, and you can take a couple of scoops of that and then mix it with the regular coffee. So it's not as flavored, but yet you're going to stretch the flavor out amongst more pots of coffee. Ah, top tip. So, again, remember guys, I only have a couple more to go here with you, and then I'll let you do some work. But when you set this up, again, it's just a matter of starting at the angle bisector and loving it. Okay? Now it looks like it has wings.
You can fly away.
8 over 12 is x over 9.
Hey now. Let's keep it PG back there.
Hey now. Here, rock star.
Yep.
Riley, don't tell me.
Yes, you do.
Right,
6 feet is 72 inches. You know that. Okay? You sold it though. Oh yeah, I know what you're talking about. So here's what happens when you start putting all of this together. Because you'll get these 3 very simple ways of working with this, but you have to be able to distinguish what to use and when. Let's see, which one was it? No, that was, oh, wrong page.
You always do that. And then she goes,
Mr. Murphy, what's your favorite thing about the holidays?
Not being around you.
And it wouldn't vote, and I wanted to know what it was. But I cannot.
I give him a little creativity on that one. You gotta let him think he's funny every once in a while, then maybe he'll.
I don't want to talk about it. I like
You know what? I agree with you.
Hey.
You know what? I just like hanging out with my kids.
there you go, yeah. Big fun?
Yeah, we're taking our kids up to the Dells. No.
My mom was talking about
Where are you going?
you.
Guys.
My mom was talking about you.
What
You're a good kid.
what my wife and I try to do. All right, guys. There's when you start to mix a bunch of this stuff together. Yes, ma'am.
You went to Cortland?
We're going before. We'll be up there before Christmas. We'll be up there before Christmas.
Where are you going?
Christmas time.
I'm going to the Bahamas for Christmas.
boys.
Do they like know or is it
Long.
So if you see my children, don't tell them. So here's what happens. Come on, guys. Ladies and gentlemen.
I just learned that his mom was a teacher that made me cry in 5th grade.
Well, let's just worry about this for right now, because like I said, right about now we're really starting to push through on this. Sometimes what happens is that you're going to wind up with multiple parts in a larger problem to solve for. So take a second and let's draw this one out. Notice that the red segment interior of the triangle is that angle bisector again. So we're going to have to utilize that a couple of different occasions. And we're also going to have to set up the idea of using similar triangles with scale factor. So you do have to mix some of this stuff together from the things that we've done over the past week or so. Now, we have what? 4 variables to solve for. We have to solve for A, B, C, and D. And what you want to start to think about is which one's the quickest one to get and how do you continually move on from there. Now, we know that you've got an angle bisector, which means you can love the problem out and around, out and around. By doing that, we can solve for D right away. D over 6 is 3 over 9.
3 over 9 is what?
1/3.
Good. So your scale factor with our triangles here is going to be 1/3. What's D? Shoot, this one. So we get 2 for D. Okay? Yeah, but I want to, oops. So I have a 2 here. But what we need to figure out is that we have this scale factor, the 3, excuse me. Okay. So if I go the next one to love, we have B to 12 as 6 is to 9 plus A. The reason I got 12 is because the two parts on the segment here were 6 and 6. The reason I have 9 plus A is because one segment is 9, the other one is A. Okay. Now, I'm continually using that idea of that scale factor of 1 to 3, because that's what I had here. I went with the B to 12 was on the bottom. The 6 to the A plus 9 is on the top. Which means that if I write it out in terms of that scale factor, I can do this twice. I can say that 1/3 is B over 12. I can say that 1/3 is 6 over 9 plus A. Excuse me. What's the B over 12? B over,
No, I said you do B over 12.
yeah, because it was the B over 12 on that side. B and then 6 and 6 was 12. That's what I said. So if you cross multiply that here, what's 3B is 12? What's B? Good.
Oh, that's not. But I didn't do that.
There's a couple of ways.
Oh, okay, because I was about to say I got 4, but I didn't do it like that. What?
Okay. If I do the other side, I get 18. Shh, guys. I get 18 is 9 plus A. What's A? 9. So what happens here is not only are you using the love setup with the heart, but you go back and fall on to the idea that you've already found an original scale factor, that you can use that when you have two variables to solve it. Sometimes it gets a little messy like that, where you can't solve for two variables at the same time, but you know what the scale factor is because you just did that 3 over 9. So you just use that again. Does that make sense? I wanted to make sure I showed you something like that because it does show up that you get some weird ones.
How do you find C?
How do you find C? C, we do the same thing. So to do C, C is actually is just as easy as D was. Now that we know that A is 9, what we would do is 5 over 12 plus C. And the other side would be 7.5 over 18. 18 and 4 is 22, so it would be 18, and 4.5 would be 22.5. Now, a couple things you can do here. You can multiply all that out by your calculator, or you should find out that this fraction simplifies to be, what do you think? 1/3. This is the same scale factor. SMRT.
Come on, he does that every single day.
So you cross multiply, you get 15 is 12 plus C. So what's C? 3. So even though that we're setting it up with that heart idea, you still, because since there's multiple parts to it, you can still utilize that scale factor. You can still cross multiply out with the decimals and still get the same answer. It just, do you have your calculator in front of you? Do you not have your calculator? That kind of stuff. Okay? Which I'm hoping that you always have your calculator because, I don't know, it's helpful. I'm what? Sorry. I'll be more pleasant if I'll get a calculator.
I don't want one. Hey, stop.
So, let's do these. I think I already posted the prompts on the calendar. I don't remember if they were.
And then it give me a date.
Yeah.
I got a couple.
I don't have. I don't have.
I like Andrew better. But the only problem is, I mean, they're kind of
So it's on page 400.
on the shortest side. I like Andrew.
I'm telling you.
Oh,
It's on the calendar. Let me get to it.
what's the problem?
How long are you guys staying?
Is that my phone?
Yeah.
Through Christmas.
Wait, when are you leaving?
Next week.
Christmas morning.
Did you want to, see my children and go sledding? Do these, please.
Wait, you're not going to like a water park?
No, we're going to stay at my in-laws got us a cottage at Christmas Mountain, so we'll go there.